So, welcome everyone to our Monday Ivan Hour, our first of this conference. I have the great pleasure to introduce Evan Williams, and was the applications director at Varian and software product manager, and then he went off and founded an airport airline. And he's a friend to many of us here that are former Varian people or dealt with Varian, probably everyone in this room. So without further ado, I will introduce Evan's talk, who will talk about the scientific career of Lloyd Jackman.
Well, good evening, everyone. As Dave so succinctly put it, I'm going to talk about the scientific career of Lloyd Jackman. And what I started to do was to talk, build a talk on his career. What I found was that was intertwined with NMR becoming not a physicist's toy, but becoming the first new age tool of organic chemistry. And whereas people like Toby have talked about the Varian side of it, what I'm going to talk about is how organic chemists came to espouse NMR as being their first new tool of application, and it changed organic chemistry. It opened people up to things like mass spec and other techniques that we've seen since, but it was NMR that changed the organic chemist from being somebody who learned some reactions and tried to apply them to stuff and hope that they got something. But they couldn't really tell what they had. And so I want to explore that as much as Lloyd himself. So without further ado, Lloyd came from South Australia in this little tiny town at the bottom of that yellow arrow. And South Australia is about as far away from even the west coast of the US as it is from Europe. That meant that when the literature came in, it was 6 months old. And you just didn't know what the rest of the world was doing. Lloyd went through college. He then went to Adelaide University, which was recovering from having no one there during World War II. And at that point, he was pretty hopeless as an academic, except for chemistry. And chemistry because he just loved to make things go bang. He moved on from that and got a number of degrees and finally was able to submit for a PhD. This happened to be the first PhD in all of South Australia from the Indigenous university system. Adelaide University is in the middle of the city, and as you can see, it looks pretty rural. His PhD thesis was on the Meerwein Pondorf reduction and its mechanism, and I've just put that down there at the bottom so that you've got some idea of that's organic chemistry. But what was the mechanism? And that all you could do was surmise. However, it was enough to get him a fellowship, and there's the front page of his thesis, which was hand-typed by his wife, and there were no carbon copies, there were no photocopiers, so when he had to submit 3 copies of his thesis, they had to type 3 copies. I just shoved that in there because I thought that was rather just a reminder of what it used to be like. And he got a fellowship to go to Imperial College in London. Now, Imperial College was founded around about 1100 AD, but it was sort of part of London and that sort of thing. But after World War II, they were able to attract a couple of fairly good classic organic chemists, and one of them we'll introduce you to in a moment. But Lloyd arrived there to do a postdoc, and I've listed there his academic positions at Imperial College. He was an assistant lecturer, which means he handles teaching or whatever, but no tenure. He was then promoted to lecturer, and that gave him tenure and the right to have his own postdoctoral fellows. In 1961, he was promoted to reader, which in the American system sort of equals a personal chair. So he arrived and started off in being assigned by the head of department. This was a Professor Linstead, who had made his name in developing dyes that could be used for printing and that sort of thing. He was assigned the task of looking at the mechanism of proton transfer and got a number of papers out of that. He then realized that he couldn't tell a lot about it, and so he decided to build a pulse calorimeter to try and measure the endotherm, exotherm profile of what he thought might be a carbocation. After a bit, he realized that other groups were pursuing the same ideas, so he tried quantum mechanics, and well, that was pretty interesting because he learned how to program in Fortran, but didn't really help. But for his efforts, he had at that point got tenure. His professor, Linstead, was then promoted to essentially the equivalent of the president of a modern university, and that left the chair vacant. It wasn't filled by Lloyd. It was instead filled by Derek Barton. And I discovered the first thing that I had not realized, and that was when I started talking about these people, no one in America knew who they were. But Barton took the chair up in Imperial College, which meant he was full professor and he ran the department. But the reason that he really became famous, in at least European circles, was he defined the concept of conformational analysis. And it was in a 4-page paper. And that gave him a Nobel Prize, because this was the first breakthrough of prediction in outcomes of a new chemical reaction. And so he encouraged Lloyd to look around, and one of the things that he suggested to Lloyd was he'd go across the road to look at what was going on in inorganic chemistry. However, in the meantime, Jack Roberts of Caltech fame came round and he held a number of lectures on NMR of that time and how he thought it was going to be critical for organic chemistry. Lloyd was particularly interested and so asked him to run an NMR of a partially deuterated sample that he had made, which would give Lloyd an answer on a question of stereochemistry. That he did, and so Lloyd then went and ran into this guy, a guy called Geoffrey Wilkinson, who had taken up the chair of inorganic chemistry at Imperial College, and he bought, well, at least Imperial College bought for him, one of the very earliest of, quote, high-resolution NMR spectrometers. It was a Varian HR30, which they then converted to an HR40. Wilkinson got the 1973 Nobel Prize for his work on the chemistry of organometallic compounds, particularly sandwich compounds, and he in his career published 550 odd papers, but he wrote a book, and he wrote it with a student of his, a guy called Cotton, and they called it Advanced Inorganic Chemistry. This covers the periodic table, and that book is still in currency. It's in its 6th edition, and as we see, Al Cotton then in due course came back to the US and made quite a name for himself here as well, more later on. Anyhow, by 1958, Lloyd had learnt not only how to run a spectrometer, but how to modify it. And that was all due to Geoffrey Wilkinson. Well, Lloyd then immediately started applying that to problems that organic chemists around him were having. So I now want to just look at where we were, not me, but they were, in terms of NMR in the 1950s. Now, I'm not going to touch too much of this because this is Toby territory, but NMR had been the province of physicists. There were 3 main groups, really. Stanford, and that, I say, includes Varian, Berkeley, and Harvard. And in 1951, you can see there that spectrum. They were the first to be able to see the 3 different types of proton in ethanol. I don't know how much was drunk after they had discovered it, but there we go. This catalyzed Varian, and in particular Russ Varian, to design and sell the first commercial system, which was the HR30. And the first one, just as an aside, was installed at Humble Oil in 1955, I think it was. I see the last digits missing. And they then employed a guy called Jim Schulery to start this novel idea of an NMR app lab with a second instrument that would help organic chemists or anyone else come to grips with NMR by running samples and publishing, that sort of stuff. Now, there were some problems. The electromagnet could run to a field of nearly 2 Tesla. However, the field was a mess. And so in order to improve the homogeneity of the field, they kept it at below 1 Tesla. Even then, the field tended to drift and was still somewhat inhomogeneous, but they felt, well, this was a good start. Now, Bloch was sitting in the cafeteria in Stanford one day, stirring his morning tea, and realized that stirring a sample in the magnet might improve resolution. And Anderson and Arnold then showed that this actually worked. So here was a step forward in getting resolution of protons in a chemical sample. There was another problem, and that is that the recorder that was used was a... Stop laughing, Paul. Was not connected either to the magnetic field nor to the frequency. You turned it on, it ran. Spectral calibration was achieved by laboriously adding a low frequency, say 100 hertz, from a Hewlett-Packard signal generator stuffed into somewhere. Could be the sweep coils, could have been the RF. And the top of those 2 spectra show a water resonance and 100 hertz sidebands. So you could measure from the center band out one and say, that's 100 hertz, or that's 7.3 inches, etc., etc. And just to prove that you could do more than that, the bottom one is beta-carotene, was in deuterochloroform, and had plenty of TMS in it, Tearsol, and they used 50 hertz calibration sidebands. So now you could get something of a handle on the chemical shifts of the protons in that molecule. Now, another thing that occurred about this time was that in October of 1958, Axel Bothneby and Barry Shapiro sent out the first issue of a letter they called Monthly Ecumenical Letters from Laboratory of NMR, or Mellon NMR, and I gather that Clemens has just been awarded a prize this year for his masterful collection of just about every issue and has posted them up on the ISMAR website. Anyhow, under various names, the newsletter continued under the guise of Barry Shapiro through 516 monthly issues, and it eventually ended in September of 2001. I think it's important to realize that the newsletter was ubiquitous throughout Europe as well as the US. So this was one of the very first truly international efforts at getting the community together. I've just picked 2 articles from early issues. On the first, the left side, you don't have to read it, but this was the starting point of the debate as to how to quote chemical shift. Did it go from high field to low field, or low field to high field? Was it tau? Was it sigma? And that was, amongst other places, fought out through the pages of about the first year of the newsletter. The one on the other side was another typical article. Oh, I've left out the 4 pages of circuit diagrams. But it was basically from Jack Roberts telling the community how to cool the water that you were using to cool the magnet. Now, there are parts of the world where water's no problem, but certainly in Southern California, they were aware of it, and certainly Caltech was. That had ramifications too later on. So, getting back to Lloyd, by June of 1958, he'd run his first NMR spectrum on the HR30, and this was a visiting academic to Imperial College, and his name was Wiley, and it solved a stereochemistry problem for Wiley. So that made Lloyd even more aware of what a powerful tool this was and how it could be transformational. So he collaborated with colleagues at Imperial College who were all sort of mechanistic organic chemists, but had no real tools other than UV visible and infrared, to solve structure determinations and structure and reaction mechanisms. So in early 1959, Derek Barton suggested, by using the royal we, that Lloyd should write a book on NMR for organic chemists. And he completed that in June of that year. There's that book. It was the first edition. It had a whole 134 pages, and it contained 220 references. And in the months after publishing that book, Lloyd started doing the European university circuits and consulting with chemists and giving seminars on getting NMR solutions to their structural problems. So he was sort of a one-man traveling salesman for organic chemistry using NMR. He then, because he kept shifting his field of focus on techniques, he loved building stuff, he turned some of his attention to the theory of infrared with a PhD student. They did a complete vibrational analysis of gas phase cyclotropine using IR and Raman spectroscopies. That was probably the first time that the two complementary infrared techniques were used to simple molecule, but anyhow, he also got a very good technician friend of his to build a double resonance channel for the for Jeff Wilkinson's HR40, and he was interested in doing proton N14 double resonance experiments. He could then start building a bit of a database on what that meant when you had nitrogen near a proton. He also got back into computing science using a horrific computer built in the UK. It was all vacuum tubes, but he was able to do theoretical calculations of complex spin systems like AMX and such things. He also started down the process of chemical shift prediction in aromatic molecules. Remember that he'd had this earlier thinking about the possibility of carbocations, and he was sure that there was some sort of tautomerism or whatever associated. In 1961, he applied for the chair at the University of Melbourne and then departed for the US to spend the summer at Iowa State University. Early in 1962, he was offered that chair in Melbourne, and at that point, Melbourne was like Adelaide. It was, they might have an organic chemist, but they had no equipment, and they were back in the 1870s, as it were. While he was waiting for the ship to take him to Australia, you didn't fly, you couldn't fly, it was 6 weeks plus in a ship. He started work on using NMR to directly observe carbocations in solution, ran out of time. What he wasn't aware of was that at the same time, as Krish is there nodding his head, George Olah had begun work on the same problem and the same general concept, and that got George the 1994 Nobel Prize. Anyhow, let's just look again at where we are in state of the art for NMR. And in 1959, Varian had made a number of improvements to the spectrometer. They reshaped the magnet pole caps, and that got them up to 60 megahertz proton frequency. Russ Varian designed a super stabilizer. Didn't work all that well, but then somebody else substituted the sensing apparatus with a galvanometer, which I'm sure was the bane of many of us older people in running a spectrometer. If you got it right, you had a field lock, the field would be pretty good. If you got it wrong, the galvo would smash off to one side and you probably had to rewire it. Yeah, they had also, yeah, oh, we'll see a photo of one. They had also added shim coils. Now, this was not a Varian invention. This was, I think his first name was Marcel Golay, and he was one of many of the other UK NMR building small companies. But he had this idea that you could actually specify your shim coils in terms of spherical harmonics, and that's how we get curvature and third order and all that sort of thing, is understanding how to design these shim coils. Anyhow, there were still two significant issues, and that was long-term field drift and how did you calibrate your spectrum? Well, here's the 1960 innovation. This is the HR 100. It's the final member of the HR series, and by this time they had a super stabilizer. If you look on the top of the magnet, there's a rectangular box, and that's the dreaded galvanometer. So it had that, and it had shim coils. Again, in 1961, Varian came out with the A60. It was a routine NMR designed primarily for organic chemists, so it had to be easy to use. It had a field frequency lock and a flatbed plotter that drove a frequency sweep of the spectrometer, and so you could use calibrated chart paper. You'd put TMS on the 0, and then the rest was magic. So now there was a good idea of how to build truly a high-resolution NMR spectrometer for protons. So you could be confident about the spectrum. Varian then realized they had a lot of HR series out in the field, and so they added those those last two inventions, the lock, usually using deuterium in a sample, but sometimes you'd use a capillary or whatever to stabilize the field, and then the flatbed plotter that allowed you to go down 2 inches, and that was 1 part per million or whatever you'd selected. And they changed the model designations for the 60 megahertz. For whatever reason, they called it a DA60, and the HR100 became the HA100. And then there were a whole lot of letters at the end that meant other things, like whether you could run an external reference for your lock, or internal, or, you know, whether it was painted darker grey or lighter grey. So at the end of 62, he departed from Imperial College by ship with his wife and 3 kids in a single cabin. And waiting for him in Melbourne were both a high-resolution NMR and a high-resolution mass spectrometer. He arrived in November in Melbourne at the beginning of summer. This is the southern hemisphere. So there's the University of Melbourne. See, it's a bit more, or a bit less wild and woolly than Adelaide, but it was still pretty much downtown, and it had a ton of room. But what he did was he took a very slow and dispirited department, and by using this sort of what he had learned from both Linstead and Barton about not making people work on your projects, but encouraging them to take their own projects and write their own papers and provide a sounding board. He also attracted, of course, the analysis tools of modern organic chemistry, such as MS and NMR, and so it became routine to use those, and that meant that stereochemistry had become a departmental strength. The problem with that appointment was that put him as the head of the department. Now, if you think that a modern university has a huge superstructure of rules, regulations, and committees and that sort of thing. It was nothing like this. So it's not surprising that although his wife and kids got to actually experience Australia, it wasn't that surprising that after a few years he moved yet again. But I just want to show you, here's before he got a flatbed plotter. The spectrum is classic in terms of what you would get. You can see the strip chart recorder. Well, that was run by a certain nephew, and who was about 15 at the time, and we had to go in to the university because he'd copied Jack Roberts' water cooler system, but unfortunately they shut down the department over Christmas. Now, instead of a fancy heat exchanger, he did the Australian thing. He put a beer cooler in. And the beer cooler, deprived of cooling or warming water on its outside leg, froze. So he had to go in and do two things. One was he had to thaw out the beer cooler and get it going. And the other was, of course, all the magnets had shut down, and so we had to get those going. And he allowed me, once he'd shimmed it and all that sort of thing, to at least record a spectrum. So I just had to throw that one in, just to show that I have done this stuff. Okay, by 1964, though, it had become evident that the first edition of the book needed updating. And so he enlisted the help of Dr. Sever Sternhell at Sydney University to co-author a second edition. And just as in parentheses, Sever was a madman. I can remember I'd visited him and he was going to take me to the airport at Sydney, and it's on suburban roads. Well, that's okay. He just drove down the middle of the road at about 70 miles an hour. I'm going, but we made it. That was typical of Sever. That was the cover of the second edition. It's 465 pages and over 2,500 references. If we look at this, you'll see that with the second edition, he hadn't bothered about other nuclei. There was just too much proton work to cover, and you don't want to hit an organic chemist with too much diversity. So, now that book, you could walk in probably today into any synthetic organic chemistry lab, and there will be a copy in each and every lab. Okay, now, while that was happening and coming out, there was a very interesting paper that got rejected several times, including the journal that they eventually managed to publish it in, and it was Anderson and Ernst with a proof of concept for Fourier transform NMR. No one was interested. And that was partly because, yes, you could apply a Fourier transform, but the Cooley-Tukey algorithm had not been published, and Varian was preoccupied with the development of the XL series of high field spectrometers all the way up to 300 megahertz. And so they just couldn't take on another thing on their plate, even though they held that patent. Brooker had introduced the HX series of multinuclear spectrometers, so Varian was under pressure. They had to catch up. But Brooker, being much more of a physics or physical chemistry-based operation, were able to add an FT accessory for their spectrometers. Even more importantly, they used initially a Nicolay 1080 mini computer. This was a bit bizarre. It was basically a PDP-8, but had a 20-bit word. That made the difference between getting a halfway reasonable Fourier transform and not. So they had an obvious advantage in that they could just plug another 3 boxes in and another rack and it all worked, but they had the Nicolay 1080. Didn't last long. They had to reinvent it for themselves because Nicolay was no longer selling to them, or whatever, I hate to think. But they stuck with a 20-bit word for quite a long time. So that was sort of in the background, bubbling. In 1967, Lloyd had accepted the chair at Penn State University. It was one of many from the US because when he had been in Iowa State, he had gone all round the universities, both in Canada and US and Mexico, lecturing on NMR and helping people interpret NMR spectra to solve their problems, not his, but theirs. So he then having gone to State College, held that chair until 1991, when he retired and became Professor Emeritus. So he was able to upgrade his NMR capacity at Penn State, and it wasn't one spectrometer. I seem to remember it was half a dozen or some incredible number. And he was able to get Fourier transform upgrades on that. And so he launched into using carbon-13 in solution to solve some of his mechanistic problems and stereochemistry problems. And this is just one example. Now, from that, due to the infiltration of a certain Alan Benessy, who quoted his old boss all the time, he got interested in CP mass. So Lloyd moved from solution state, remember he's an organic chemist, into the joy of doing solid state NMR, which he didn't do exclusively, but it really helped on certain occasions. Well, then he went down extremely the dark side and ended up looking at quadrupolar nuclei. And there's a couple of papers there. He was really interested in things like lithium, aluminium, or aluminum hydride, and how it worked on the various types of chemistry that you could use it for. Of course, it was sort of a love-hate relationship because the Meerwein-Pondorf reaction was completely thrown in the garbage bin by the initial use of lithium. Anyhow, just to rub salt well and truly into the wound, here is a NMR newsletter from 1991 on using lithium-7 powder patterns, which he didn't get quite right, but anyhow, you know, that wasn't your fault, Paul. Okay, so we're getting to the tail end of this story. This is an interesting exercise in AI. I looked up trying to find a definitive list of Lloyd's publications. So far, there's another 100 that I haven't been able to pin down, and that's because they were published in Australian journals. But here's what AI found. You can see that his rate of publication from the very early days was pretty much flat until he retired and a bit after. But look up the very top, if you can see it. It's got his ranking as citations in various fields. And in NMR, this AI, GPS, came out with him as number 1. Still, with 100 or more. Pretty much it. And, you know, what I sort of want to get as a takeaway is that NMR became so popular because of very few people who were organic chemists not only started grappling with it in the early days, but went around various countries and that sort of thing, helping other organic chemists to come to grips with it. And, you know, the names that spring to mind are Jim Shorey, Jack Roberts, the duo of Osnaby and Shapiro, and Lloyd. And Lloyd primarily because he was able to write 2 books that were state-of-the-art at the time, but made it understandable and useful to organic chemists who hadn't ever dealt with anything more difficult than using a neutron mold for an infrared spectrum. So, other than that, but with one totally separate thing, I just want to say as a totally separate thing that I had had a very good friend in Australia. He was a Czech. He had got out of Czechoslovakia before it had gone all upside down, and it worked for a company called, believe it or not, Tesla. this was a very different Tesla. It built NMR. Don't know how good they were, don't know how bad they were. He ended up at Brooker. And he knew a bit of German, that helped him. But when I installed my first spectrometer from Brooker, it was an 890, it didn't work. Well, that was typical of early Brooker spectrometers. Eventually, they sent this guy to teach Carhart now. And I taught him English. He taught me how to cook pork shanks. And he taught me a lot about hardware, NMR hardware. Well, we lost touch when I left Australia, and I just got an email from a mutual friend of Peter and mine, and maybe a couple of other people around here, Bill Keane, and he told me that Peter had died. He'd died in Australia because he'd taken on Australian citizenship. That was his country. So, I don't know how many people here would ever have heard of it, but he turned Australia from Varian into Brooker, essentially single-handed. And, I think most of his peers are dead now, but I just had to say it.
Thank you, Evan. That's what a wonderful history. Yeah, and all those names. So, yeah, let's have some questions and discussion. Oh, yeah, I'm sorry.
I don't remember Anne, but I think she was at Penn, not Penn State.
Oh, you're right. Yeah. Good.
But Lloyd did have an interest in NMR of proteins, and he had one of his people who did a lot of protein work. It was a woman called Juliette Lecomte, and I've forgotten where she's at now, but she was pretty early on in the 3D NMR, 2D NMR of real proteins.
Well, no, I mean, Alan McDermott, though, is...
Sorry?
Alan McDermott was organometallics. Got the Nobel Prize, went back to Australia after being at the University of Pennsylvania. I was just curious if he and Jackman ever ran across one another.
Yeah, I don't know, because Lloyd knew just about anyone.
Oh, yeah, no.
But Anne never has spoken to me about it. Mind you, because no reason to, the topic never came up. Yeah, the topic never came up, but Nick Severini was one of Lloyd's. I mean, he had something like, when he was at Penn State, I think something of the order of 30 of his ex-students or postdocs now in academic positions. He was one of these people who would suggest but never chastise, and if you did some work, it was your publication, not his. But, and he learnt that from the guys at Imperial College. So, now I'm in trouble.
Yeah, no. I have to, of course, have a last word here, but for those of you who haven't been to Penn State, the NMR Centre there is named for Lloyd. It's the Memorial NMR Centre for the new, what did they put in there?
Brooker 850.
Brooker 850, so, which is really quite touching. But also, I can recall coming down here to one ENC and hearing Lloyd present on lithium chemistry. And honestly, I fell asleep. I mean, it was just so esoteric, but it was quite an extraordinary presentation, and people told me that it was important.
If I may, just want to add a personal anecdote about that book. It's a personal anecdote about that book, that Jackman Sternhell book. 74, I think, I think it's 74. I was an undergraduate chemistry student, passionate about chemistry. Won some competition. I was awarded this book as a prize. Right. During my master's, I fell in love with NMR. And here I am. So that's book changed what I wanted to do.
And by the way, I don't know where my original copies of either are, but a year or so ago I started shopping around and I got a couple of early editions for the first and the second. It was interesting to see the names of the original purchaser. And one of the big time purchasers was through DuPont. And that was another factor that I didn't go into, but right from the early stages of variant selling, high resolution NMR, the American manufacturing industry was one of the first and foremost. The very first HR 30 went to be a 40 that was sold was to Humble Oil. In fact, it was the first installed in the world. And Jeff Wilkinson's HR 30 was the first in the UK, certainly, probably Europe. It was interesting because that spectrometer was installed by a guy called Warren Proctor. And Warren said to Jeff Wilkinson, "Oh, you know that this isn't just an NMR spectrometer. You can run EPR on it as well," or ESR, whatever word he used. And Jeff took him at his word and got a sample of a free radical and held it near the magnet and measured its EPR spectrum. And that locked him in. At that point, he had the spectrometer, the best of both worlds. And what's more, he had this bright young dude, Lloyd, that he could teach NMR to. So, you know, just shows it was a small world.
I think I seem to remember a third Jackman book called Dynamic NMR.
Yeah.
Because that's the one I always read, Dynamic NMR. I thought.
Oh, you've got that. Oh, I've managed to buy a copy, but it's on a ship coming from the UK. But yeah, so at least the first volume was Cotton and Jackman as editors. I don't even know who published chapters in it. You know, that's to be seen. But that was another thing that the AI didn't ever find. So, you know, I stumbled across it 2 weeks ago and I thought, oh, didn't even have an index, so I wait to see. Well, thanks, guys. Thanks for your patience while I rambled around various topics, but hopefully there was some good that came out of it.
Evan, really nice history lesson, and especially in regard to such a luminary in our industry. I was going to say in our field, but that would be a stupid pun, of course. No, really nice job, and our Ivan group is going to preserve your remarks and your commentary from this evening, and I wish there were some number of the young folks in the audience that would maybe find this as valuable or even more so than, can I say old timers?
Yeah, you can. But one thing that I will say is there was a hell of a lot of research that went into digging this stuff out. I tell you, we're in danger of losing our own history. And I don't mean just here, I mean NMR is going to end up in the mists of time, and no one will be able to say, well, who was Wes Anderson? Or, there'll be a few people that get remembered. Richard Ernst is one. But I just wish that I had more time to actually come and hear about Alex Pines, who I didn't know well, but I knew him, and I would be interested to get a much more full picture of his career too. I mean, it wasn't all that far away. But, hopefully, you'll be able to post the recording.
Yes, I think that's one thing that John and Ivan wanted to do this on a regular basis. Remembering these times and preserving that information.
This is not for naught. This will be around for a long time to come. And,
Yeah.